Welcome to this deep dive. Today, we're really getting into the work of computer scientist Jim Gray.
Yeah, he's a name that, well, maybe not everyone knows, but his impact is just enormous.
Right. Especially in things like data management, transaction processing, stuff that basically makes the modern internet work.
Absolutely. He laid down some really crucial groundwork back in the day, foundational stuff.
And it's not just the tech, is it? There's that other layer to his story, the mystery.
The disappearance at sea, yeah,
Yeah,
it adds this whole other dimension, a brilliant mind, fundamental concepts, and then this totally unresolved ending.
exactly. So that's our mission today, really, to explore Jim Gray's key technical achievements. What did he actually do, and why does it still matter so much?
And we'll also, yeah, touch upon the mystery surrounding his final days to try and get a fuller picture.
Okay, so where do we start? His foundational contribution seems like the obvious place.
Definitely. And you really can't talk about his impact without starting with ACD transactions. That's probably the absolute core.
ACID. Okay, it sounds technical, maybe a bit chemical, but it's an acronym, right?
Yeah, not chemical. It stands for four key properties that guarantee reliability in database transactions. He was really instrumental in formalizing this.
So let's break it down. A is for
Atom City. Think of it as all or nothing.
all or nothing.
Yeah. Either every single step within a transaction completes successfully or the whole thing is rolled back. Like it never happened.
Okay, makes sense. Like sending an email with attachments, you want the whole thing to go, or none of it.
Precisely. Prevents those weird partial states. You wouldn't want, say, money debited from your account but not credited to the recipients.
Right. Okay, A is atomicity. What about C?
C is for consistency. This means a transaction takes the database from one valid state to another valid state.
Valid state meaning it follows the rule.
Exactly. It preserves data integrity according to whatever rules are defined, like ensuring a bank account balance never goes below zero if that's a rule, or that every order has a customer ID associated with it.
Got it. So atomicity is the all or nothing. Consistency keeps the data correct according to the rules. What's the I?
E stands for isolation. This is super important when you have lots of transactions happening at the same time.
Which is pretty much always these days, right? Online shopping, social media.
Always. Isolation ensures that concurrent transactions don't interfere with each other. It's like they're running completely separate, even if they're accessing similar data.
So my bank balance check doesn't get messed up because someone else is making a deposit at the exact same millisecond.
That's the idea. It prevents errors and unpredictable results from concurrency.
Crucial. Okay, A, C, I. What's the D?
D is durability. This just means that once a transaction has been successfully committed is the term, the changes are permanent. They'll survive system crashes, power outages, whatever.
So once you hit save or confirm that transaction, it's locked in.
Locked in. Even if the server bursts into flames right after, metaphorically speaking, that committed data is safe.
Wow. And these ACD principles, they're still the bedrock for modern databases, like PostgreSQL SQL Server.
Absolutely fundamental. It's amazing how durable, no pun intended, the concepts themselves have been. They underpin so much of the reliable online world we take for granted.
Incredible. And Gray didn't just, define ACID. He figured out how to actually build systems that followed these rules even when things went wrong.
Exactly right. His work on fault tolerance was just as important. How do you make these transactional systems robust? How do they recover from errors?
Okay, so how do you do that?
Well, techniques like logging were key. Keeping a detailed record of all changes, so if there's a failure, the system can retrace steps and restore consistency.
Like a flight recorder for the database?
Kinda, yeah. And he also worked on commit protocols, especially for distributed systems where a transaction might involve multiple computers. The most famous is the two-phase commit.
Two-phase commit sounds deliberate.
It is. Imagine booking that flight and hotel package online again. Two different systems, maybe. Two-phase commit ensures either both the flight and hotel get booked, or neither does. Phase one is the prepare phase. Everyone involved signals if they can commit.
Like asking, are you ready?
Yeah. And if everyone says yes, then phase two is the commit phase. Everyone makes the change permanent. If anyone says no in phase one, the whole thing is aborted.
So no booking a flight to nowhere with no hotel room.
Exactly. It guarantees atomicity across multiple separate systems, hugely important for banking, airlines, e-commerce. anything complex and distributed.
And you mentioned this connects to cloud systems today.
Absolutely. Think about the scale of cloud databases. They're massively distributed. The principles Gray worked on for reliable, fault-tolerant distributed transactions are, well, they're essential for making the cloud work reliably.
Okay, ascity, fault tolerance, reliable transactions, huge contributions. But he also thought about the nitty-gritty, like memory versus disk. Tell us about the 5-minute rule.
Ah, the 5-minute rule. Yeah, this is a classic. He developed it with Franco Puzzolo back in '87.
What was the idea?
It was basically a cost-benefit analysis. How often does a piece of data need to be accessed to justify keeping it in expensive, fast RAM versus cheaper, slower disk storage?
And the answer was 5 minutes.
That was the calculation back then, based on the relative costs and speeds of RAM and disk at the time. If you access something more frequently than every 5 minutes, it was cheaper overall to keep it in memory.
But the main point wasn't the exact time, right? It was the principle.
Precisely. The principle of quantitatively analyzing the trade-off in the memory hierarchy. Technology changes, RAM gets cheaper, disks get faster, SSDs came along. The 5 minutes might be seconds or milliseconds now, but the way of thinking about it, that's endured. It's still fundamental to system design.
A really practical, enduring insight. Okay, shifting gears a bit. From memory trade-offs to just handling sheer amounts of data. Big data. Gray was into that early too, wasn't
Oh,
he?
yeah, big time. At Tandem Computers and later at Microsoft, he was a real pioneer in massively parallel database systems.
Parallel meaning. Doing lots of things at once.
Exactly. Breaking down huge database tasks, queries, data loading, whatever, into smaller pieces that could be processed simultaneously across many, many processors. He saw that single systems just weren't going to cut it as data volumes exploded.
Which they definitely did.
For sure. So his work was foundational for data warehousing, for systems like Teradata, for the parallel capabilities in SQL Server, and really for the whole architecture of modern big data platforms. How do you manage and analyze petabytes of data? A lot of the answers started with Gray's work on parallelism.
And it wasn't just about business data, right? He saw the potential for science, too. This eScience idea.
Yes. In the early 2000s, he became incredibly passionate about eScience, applying these data-intensive computing techniques to scientific research.
Like in astronomy or genomics. Fields generating just massive data sets.
Exactly. He saw that science was becoming data-driven in a whole new way, and that computation was the key to unlocking discoveries hidden in that data flood. He called data the fourth paradigm of science after empirical, theoretical, and computational simulation.
And he actually worked to make that happen, not just talk about it.
Oh, absolutely. He was a huge advocate for open access to scientific data. He was instrumental in projects like SkyServer.
SkyServer that made astronomical data available.
Yeah, data from the Sloan Digital Sky Survey made it accessible to astronomers, students, even the public, all over the world via the internet. A massive undertaking.
That's fantastic.
And also the Worldwide Telescope, another project he championed. It's this amazing virtual telescope, letting you explore astronomical data visually. It was actually dedicated to him after he disappeared.
A fitting tribute. It shows that commitment to democratizing knowledge. And the field recognized his contributions, obviously. The Turing Award.
Yes, the big one. The ACM Turing Award in 1998, kind of like the Nobel Prize for computing.
And the citation specifically mentioned databases and transaction processing.
Yep. Seminal contributions to database and transaction processing research and technical leadership and system implementation couldn't be clearer. It cemented his place as, one of the giants.
And he worked at some key places, too. IBM, Tandem, DEC, then Microsoft.
Right. A really broad range of experience. He joined Microsoft in '95 as a technical fellow, which is a very prestigious role there. Gave him a lot of freedom to pursue research.
And if people listening want to read his actual work, any key papers or books?
Well, the big one is the book Transaction Processing, Concepts and Techniques, which he co-authored with Andreas Reuter. It's often called the Bible of the Field. Still relevant.
The Bible, okay.
And maybe his earlier paper from 1981, The Transaction Concept, Virtues and Limitations. That's where he really laid out the ascity properties. Foundational reading.
Good recommendations.
Yeah.
So an incredible career, just transformative work.
Sure.
Which makes the next part of the story even more jarring, his disappearance.
It really is a complete shift. So January 28th, 2007, he sets out alone from San Francisco Bay on his sailboat, the Tenacious.
A 40-foot boat. And he was an experienced sailor, right?
Yes, very experienced. His plan was to sail out near the Farallon Islands, just off the coast, to scatter his mother's ashes.
And the conditions were okay that day.
Reportedly, yes. Clear weather, which makes it even stranger. There was no distress call, no signal from the boat's EPIRB, the emergency beacon, just silence.
Vanished. That must have triggered a massive search.
Oh, huge. The Coast Guard searched for 4 days. Planes, helicopters, ships covering, I think, hundreds of thousands of square miles of ocean.
And found nothing.
Absolutely nothing. No debris, no oil slick, no sign of the boat or of Jim Gray.
But the search didn't stop at the Coast Guard, did it? There was that tech community effort.
That was remarkable. Friends, colleagues, people in the tech world who deeply respected him, they organized this unprecedented effort. They got access to high-resolution satellite imaging of the area from around the time he disappeared.
And then
And then they used Amazon Mechanical Turk. Thousands of volunteers online looking through these satellite images, pixel by pixel almost, searching for any sign of a 40-foot sailboat.
wow. Using crowdsourcing to scan the ocean from space. Well, it feels like something Jim Gray himself might have appreciated, in a way.
It does, doesn't it? A data-intensive approach to a real-world mystery. But sadly, even that massive effort didn't turn up anything conclusive.
So the surface search was suspended?
Hmm.
And then they looked underwater.
Yes, later there was a sophisticated underwater search using sonar, remotely operated vehicles, trying to find wreckage on the seabed. That also ended in May 2007, again with no results.
Gone. I remember reading something about why there might have been no debris. An expert's theory.
Yeah, a marine search expert, Bob Bilger, pointed out that his specific type of boat, a CNC-40, particularly if it suffered, say, a major collision or structural failure, could potentially sink incredibly fast.
Like under a minute fast.
Possibly, taking everything down with it, leaving very little, if anything, on the surface. It's a plausible, though obviously tragic, scenario for why nothing was found.
A grim thought. And eventually, after years passed.
Yes, 5 years after he went missing, on January 28, 2012, he was declared legally dead in absentia. It provided some closure, legally speaking, but the mystery itself, of course, remains.
Such a strange, sad end to a story defined by so much clarity and achievement. But his legacy, the technical work, that's incredibly solid and lasting.
Undeniably, his ideas are embedded in the systems we use every single day. And his influence continues in other ways, too. Microsoft Research created the Jim Gray Systems Lab in Madison, Wisconsin in 2008.
Right, focused on data management research. And led by David DeWitt, his friend and former student.
That's right. A very fitting tribute, continuing the work in his spirit.
And there are awards in his name, too.
Yes, Microsoft Research gives out the Jim Gray eScience Award. It recognizes researchers doing outstanding work using data-intensive methods in science, exactly what he was so passionate about later in his career.
That's right.
And Sigmode, the big database conference group, has the Jim Gray Doctoral Dissertation Award, recognizing the best new PhD research in the field each year.
So his name lives on, encouraging the next generation in the areas he pioneered.
Absolutely. From the core principles in cloud databases like, Amazon Aurora or Google Spanner, to these labs and awards, his impact is still very much alive and well.
It really is a story of contrasts, isn't it? This immense foundational contribution to the digital world, building systems based on logic and reliability.
Set against this complete mystery, this disappearance into the vastness of the ocean, it's quite profound when you think about it.
His work was all about making data reliable, accessible, understandable. And yet, the data about his own final hours is just missing.
It's a powerful reminder, maybe, of the limits of knowledge, even in an age defined by data. But his commitment, his vision for what data could do, that continues to shape our world every day.
Definitely something for you, the listener, to reflect on how these fundamental ideas about data reliability underpin so much, even as the man behind some of them has this unresolved story. If you want to dig deeper, definitely check out those papers we mentioned or look into the work of the Jim Gray Systems Lab.
Yeah, there's a lot there. A truly remarkable figure.